We will now take a look at how we can cache the simulation. So first of all, I will turn off the collision geometry and the cannonball. These two won't be rendered. I will dive into the geometry node for the building demolition. And let's take a look at this final DOP network that we created. So usually you don't want to just render this DOP network and calculate it each time you want to render or you want to play the simulation. What we usually want to do is, first of all, cache this information. And one very important thing that I usually do is not cache the actual geometry, but rather points that represent the transforms of each piece, and then drive these pieces with a transform pieces node. So let me show you and do this together. I will lay down a DOP import node just below my DOP network and click on display. So the first thing I need to do is point towards the DOP network that I want to import. I can do this by dragging the actual DOP network node here where it says DOP network. Now another thing that I need to do is tell the node which object I want to import from this simulation. In this case, it's just a building. So we can copy the name of this node, jump back, and here under the object mask, paste this name. Finally, we can change the import style. So for now, let's fetch the geometry from the DOP network. So here we're seeing the entire geometry of the building. But as I mentioned before, this is not exactly what I want to do. Let's try this. Change the import style to create points to represent objects. Now, what this option is doing is importing points with the name of each piece. So if we take a look at the geometry spreadsheet, these points have a name attribute that matches the name of the pieces that were simulated. So what we can do now with these points is drive the static geometry of the building and transform all these pieces with the actual points. So let's create a transform pieces node. And what this node will expect is 3 inputs. First of all, the geometry that will be transformed, in this case, the fractured building. So let's connect this first. In the second input, it will expect the points that will drive this geometry. So in this case, it's the points that we just imported. And the third input will expect a static version of these points. So to do that, we can create a time shift node, connect the points to the time shift, and here under the time shift, shift control click on the frame property to only display the frame 1 of this animation. So let's connect this to the third input, display the transform pieces node, and let's see if this is working as expected. And it is working. So there's several advantages to using this transform pieces node. First of all, when we cache these points, we will have very small files. Another important thing is that we can later change this geometry for a higher resolution geometry, maybe with all the edge detail and the interior details. But in general, this is the suggested workflow, especially if you have very large simulations. So the final step would be to cache these points to file once we are happy with our simulation and render the transformed pieces. So let's cache the points. For now, I will disconnect the points, bring this node down, and add a ROP geometry output. Connect the ROP geometry to my import points. Change the name to demolition sim or demolition sim points. And what I usually like to do is create a folder where my hip file is with the name of my file, in this case the $hip name. So here I will create this folder, and the resulting files will have the name of this node as a suffix and the frame number. So we can add a padding of 4 and change the render current frame for render frame range. We also don't need 240 frames. We can leave this at 120 and hit the save to disk. So this might take a few seconds or a few minutes depending on your simulation, but once the simulation has been cached, we can read back in the simulation with a file node and connect that to our transform pieces node. So now that the entire cache has finished, I will lay down a file node. I usually like to color these nodes blue. Then I can channel reference the name of this output. So I will copy this parameter and paste it as a relative reference here on the file name. And here I have my simulated points. So all we need to do is connect these points to my transform pieces. And probably lay down a null. And call it out. So this would be the actual geometry that we would render. So of course, for the purpose of this class, we used a very low resolution mesh. I want to show you the result that I came up with a high resolution mesh and some textures applied. Of course, I iterated a bit more with the explosion. And I also played with the strength of the constraints. So for now, this is what I wanted to cover in volume 2. And I hope to see you in volume 3 to create secondary destruction and start adding much detail to this simulation. I really enjoyed creating these contents for you, and I hope to see what you can come up with.